Hello guys, welcome to Crown Smart. In this video we are going to show the range of the following functions. Now there are two ways to find it. It's either by analyzing it without sketching it, or you simply sketch the graph. Okay, range is simply the output of a function, the set of outputs of a function given an input, or simply those set of values that are being assigned to those values in the set of values in the domain. Okay, so now I want to solve for the first one, which says that your f of x is 2x plus 3. Since the range is simply the output, so we will need the domain. Now the domain for this one in our last video is all real numbers, that is minus infinity to infinity. Now by sketching it, this is by analyzing it, because you are going to analyze it. Let's say this is for the x part and this is for the y. Now remember that if x is 0, y will be 3. So if x is 0, y will be 3. Now going through the negative part, we know we can't put this because this is not included. So going through the negative part, if I take x to be minus 5, then 2 times minus 5 plus 3 will be, this will be minus 10 plus 3. So 3 minus 10 will give me what? Minus 7. So I'll have minus 7 and I'll have what? Minus 5. So if I keep going, if I keep increasing my values to the negative part, I'll keep having my corresponding value of y will keep increasing to what? The negative part. So it is increasing to minus infinity. Now the same thing applies if I do the same for the other part. If my x is 5, then this will be 2 times 5 plus 3. 2 times 5 is 10 plus 3, that will be 13. So this will now be 13, and this will be now increasing. If I keep increasing my value of x, then I'll be increasing towards the positive part. Okay, so my range here will be all real numbers, minus infinity to what? Infinity. In general, a linear equation like this, the range is all real numbers and the domain is all real numbers. Now the next one, we are going to find the range of a quadratic function. Now we have our f of x to be what? X squared plus 5x plus 6. Now the shorter way to do this, two things we are going to consider. Now we know that a quadratic function can either be in this form or in this form, where you have this as your minimum point and here as your maximum point. Now if this is in this form, it means that x squared is positive, and if this is in this form, it means that this is minus x squared. So now, since we know that the function given is x squared, since this part is positive, it means that we're going to have a function like this. Okay, now another thing we need to find is the minimum point. Now the minimum, this point, let's say this is x naught comma what? Y naught. Now let's say this is your graph. Let's assume that this is your graph. Okay, now your range will be from this minimum point, from herewards to a certain value. If the function is increasing upward, then it is increasing towards the infinity part, meaning it is starting from here towards the what? Infinity, right? Now we want to know this particular value. Remember, this is f of x against x, so we're looking for the value f of x. So that f of x is actually your y. Okay, so that means you are looking for this particular value of y, and the faster way to do it is to use the formula. The formula is actually y is equal to 4ac minus b squared all over what? 4a. Now where you have a, b, c. Now this a, b, c represent the coefficient of this. Now your a here is equal to 1, your b here is equal to 5, and your c here is equal to 6. Okay, now using the formula, we have this as 4 times 1 times what? 6 will give me what? 24 minus, what do we have here? Your b square, which is, your b is 5, so your b square is what? 25 all over. Now 4 times 1 will give me what? 4. So this is minus 1 over 4, which will give me minus 0.25. So from this point here, I have it as minus 0.25 for the y part. Now remember, since the function is in this form, meaning that it is increasing like this to what? The positive infinity. So the range will be from minus 0.25 to what? To infinity. Okay, now the same thing applies if we solve for the second one, x squared plus 4x plus 4. Now I told you that since this is positive, it means that the curve is in this form. Now we have here to be the minimum point, okay, meaning that let's assume that the graph looks like this. Actually, this is not actually how the graph looks like, but let's assume that the graph looks like this, meaning that the point to start from, okay, let's not do this. Let me do something like, because I know that this graph will look like this. Let's not confuse it anymore. So let's say this is where the this is how the graph looks like, okay. Now remember that the range is, this is f of x against x, so the range is going from this point upward. So we are looking at the values, all possible values of f of x, so starting from this point, and it is moving upward. Now to find the possible that value of y, we use the formula, okay. Now we have that our y will now be what? Now this will now be, since we have this as x squared plus 4x plus 4, we have a, b, c. So our a is 1, our b is 4, and our c is 4. So here we now have 4 times 1, 4, times 4, 16. Now b squared, which is 4 squared, is what? 16 over what? 4 times 1, 4. So this will be 0 over 4, which is what? 0. So our corresponding value of y is from 0 to what? Infinity. 0 included to what? Infinity. So that is the range for this. Now the next one is okay, let us do the other one, which should be faster. The square roots of f of x equal to the square root of x minus 1. Now remember that the domain for this, in our previous video, the domain for this was 1 to what? Infinity. We found the domain to be 1 to what? Infinity. Now sketching this, we have this as 1, we have this as what? Infinity. Okay, this is for the x part. Now let's now see the range. Now remember that the range is actually those outputs giving what? The input. So if I input 1 here, I have here as 1 minus 1 to be 0. So the square root of 0 is what? 0. Okay, now that is the output of this, right? So if I now keep imputing values here, let's say if I input 2 minus 1 is 1, so square root of 1 will give me what? 1. So if I keep imputing those positive values, I keep having a corresponding positive value. So this goes to what? Infinity. Therefore the range of this function is from 0 to what? Infinity. Now the last one is the ln of x minus 1, and from my previous video, the domain for this is what? My previous video, the domain for this is from 1 to what? Infinity. That's my previous video. The domain for this is 1 to infinity. So if you watch my previous video, you're going to see how I found the domain for this. Now sketching this, you have this is 1 to infinity, where 1 is not included. Okay, where 1 is not included. Now observe that, let's say pick a value 2. Okay, let's pick a value 2. This is for the x, this is for the y. Let's pick a value 2. If I put 2 minus 1, I have what? 1. Now ln of 1 will always give me what? 0. That is, ln of 1 will give me 0. Now observe that since this is 0, it means that any other value that comes here will be what? Positive. So this will be to positive infinity, right? So let's say if you have 3 minus 1 will give us what? 2. So ln of 2 will always be positive. Now also observe that any value I pick here, let us say value before 1, let us say 1.1. 1.1 minus this will give me 0.1. Now ln of any 0 point, any value will give me what? Ln of 0.1 will give me a negative value. So the negative values lies between here. Now observe that a number closer to 1, let us assume a number closer, let us say 0.00001 is very close to 1. Okay, no, sorry, 1.00001 is very close to 1. Now if you do that minus 1, you have 0.00001. Now do the ln of it, you observe that the number keep increasing to the negative value, keep increasing and keep increasing negatively. Okay, because we can't actually say for sure the number that is very, very close to 1, because we can still have 1.0000000000001. So we can't actually say for sure the number that is actually close to 1. But when we keep imputing those values closer to 1, like as we keep approaching 1, okay, we observe that the values we are getting, the output we are getting is approaching what? Minus infinity. Therefore, the range of this function will be from minus infinity to what? Infinity. This is something you use your calculator to check. Okay, so as you keep approaching 1, you will not reach 1. Just keep approaching 1. Discover that the values you are getting is approaching what? Minus infinity. So this range is what? Minus infinity to what? Infinity. So thank you guys for watching this video. Please do not forget to subscribe. Please subscribe this video. Thank you very much.